Well, with the help of a friendly helper on Wikipedia and somebody who was corresponding with me and a forum that I parachuted into and started a little dialogue on Joseph Newman's energy device. With all those guys' help, I learned that I had to make some changes in the circuit simulation of Joseph Newman's motor. But despite some of the eccentricities of the output, I managed to do 4 things that Dr. Hastings measured in his analysis in chapter 6 of Newman's book. The most important thing is that the amperage coming from the battery pack be at least a little bit on the negative side. And here we see it wavers. It goes up to a high of 35 amps and then it goes down to a low of negative 42 amps briefly in both cases. Otherwise, the midline, the baseline, is 0. Well, no, the average actually would be above 0. Or below 0, I should say. Right, it would be below 0 because that's a spread of 70 plus 77. It's a spread of 77 amps, which shouldn't surprise me because it's a factor. Sorry. It's a factor of the volts out on the coil, occurring on the coil. It tends to go that way of late. So let's see, the midline would be 3.5 amps negative, wouldn't it? Right, 3.5 negative amps. That's the baseline. So actually it's negative on average for most of the time. That's pretty good. So that's not just slightly. Well, yeah, it's supposed to be slightly. It's not a whole lot. Okay, so that's one point. The other point was that the voltage out on the coil, my target was 667 volts derived from the measurements that Dr. Hastings made. And I managed to come up with 770, everything else considered, everything working together. Now I was corrected on the switching for the input, how to chop it. And I was corrected, well, that solved another problem in which my voltage in tended to go to 0. Now it sustains itself at 300 volts DC. What else? Oh yeah, the commutator, everything else was okay. Oh, and these sine waves started to come into more alignment. They were like 180 degrees out of phase, which is probably a good thing, except those simulations were not correct. They were flawed. So now I've got the voltage and the amperage on the rotating magnetic field out of sync with each other, out of phase by, it looks like, 90 degrees. Same thing on the coil, and that's shouldn't be surprising because I have a capacitor across the coil. And oh yes, I had to do something else. I had to swap the polarity on the AC rotating magnetic field produced by the rotating bar magnet, which, don't ask me what that means in real life. I have no idea, but I had to do that because it was very hard to influence the current of the battery to make it go negative once I corrected some of my other flagrant flaws. It was very hard They wanted to remain square waves in similarity to the square wave DC pulse coming in from the battery pack. It was a fight. It was a tug-of-war between two voltage sources, two power sources, the battery pack and the energy contained within the magnet that is now put into rotation, rotary motion. It was very difficult. And waves tend to change in this device when you first start it up, so I have to let 100 seconds go by before I even start to trace, have the simulator draw out the tracings. So I wait for it to stabilize, and that took about 100 seconds, so more or less, something less than 100 seconds. Somewhere between 10 and 100, I don't know. So I pegged it at 100, and it worked very nicely. Nice stable waves, nothing growing. Yeah, this one I think in the middle tends to grow, the voltage out. Oh, the watts. Well, it would be then the... Oh, it would... Well, one of them, or both of them. Yeah, the output tends to have to accumulate on the coil. It takes a while for the coil to soak it all up and become stabilized. What else? I had to do something else. So I had it in order. So I was focusing on the outcome, duplicating what Dr. Hastings described, rather than what Newman did to produce that. So that meant I was free to do whatever I wanted to on the values of these things, and so I lowered the resistance associated with the coil to a one-to-one relationship in terms of unit value. 10 millihenries on this coil, 10 milliohms on its resistor next to it. And I had to lower the henries and the resistance on the actual coil. It was 16 kilohenries with 50 kiloohms, according to Dr. Hastings, and I had to lower it. The capacitor Newman didn't specify. He just said use as much as you can, use as much as you have to get rid of spikes, which, well, he didn't say spikes, to get rid of arcing on the commutator, which is represented by spiking on the waveforms. And I did that because if you go any higher, there is a limit. It's a narrow window. I think it's like 50 to 100 milliohms, or excuse me, millifarads in this example. Because if you go to any higher, you're no longer able to transfer the curvature of the AC sine wave down to the battery pack in order to influence it to become negative. And what that means to me is that the capacitor becomes a decoupling capacitor, a bypass filter, a bypass capacitor, in which it soaks up all the AC coming from the rotating magnetic field and doesn't let any of that AC go to the actual coil, the copper coil that is part of Newman's device. Only the DC gets to go. That's why it's called a bypass filter. The AC gets bypassed. It gets soaked up by the capacitor. And that's no good. We have to let some of that AC peep through and make an influence, an impact upon all the way down to the batteries. It has to go through the coil, all the way over to the battery pack. And that's quite a haul to get through these barrier reefs. There's several barrier reefs here. So V3 has to go all the way over and overwhelm VBAT1. And I managed to get this shape wave no matter what. I couldn't do any better. This was the best I could do, was to get this shape of a wave, which is kind of weird looking, to put it mildly. Well, this is kind of wiggly, but that's not surprising because it's a blend of these two. This is the watts. So I have a spread of 10 positive kilowatts to negative 12 kilowatts going in from the battery pack. So the average of that would be negative 1 kilowatt. So it shows that you're charging the battery pack with 1 kilowatt negative 1 kilowatt on average. And then the energy coming out that's in the coil is a spread of 6 megawatts to negative 6 megawatts. So the average is 0, but because that's an AC situation that's not shifted, unlike these two bottom graphs, this one's hovers around the midline. But then the volts, we'll see now the current on the coil, again, is a spread between positive 12 kiloamps and negative 12 kiloamps. But the volts, it looks like it goes slightly negative, because it goes from 770 volts to negative 70 volts. No, actually, the baseline is in the middle. The baseline is below 350 volts. Or it is 350 volts. Is that it? 800. No, it should be something else other than that, because 70 plus 770 is 840, and half of that is 420. So 420 positive volts should be the baseline here. Anyway, I don't know. Oh yeah, well, the wattage being contributed by the rotating magnetic field in this example has a spread of 630 gigawatts positive to 360 negative gigawatts. That's quite a spread. Yeah, because you've got a spread of 4.2 megaamps positive negative, and a spread of 350 kilovolts versus negative 250 kilovolts on the rotating magnetic field. Anyway, so what else? So I managed to uphold a few of the basic premises to Newman's device within the context of this simulation, and I call it version 7, and I have 2 copies, one on Wikipedia Commons and the other on archive.org. I guess that's all I have to say. Not much. But the few people who are criticizing me, who are knowledgeable in this field, I take their criticisms. Oh, seriously. One of them was that I should internalize the resistance and the capacitance inside the inductor, and it can't be done in my simulator with the resistor. Nothing happens. It's like there's no resistance. So I have to have the resistor on the outside as a separate component. And because the capacitor is a separate component anyway in the build, why should I internalize it inside of the inductor? And I do get different results. I get some results, in terms of presence, unlike the resistor. The inductor does recognize if I put parallel capacitance inside the inductor, I get a result different than if I don't put it there at all. But if I put it on the outside, I get different results than if I internalize it. And I figure I'll put it on the outside because that's the way Newman built his device. He didn't have a Tesla. A true Tesla coil is a coil that has spacing between each turn on the coil. It might only be 1/8 of an inch, and so you have to create a wooden armature or a plastic armature with grooves to lay in each turn of your coil so that they're evenly spaced all the way around, wrapping your cylinder, and it can only be one layer. And so the wires now have capacitance between them. That's a true Tesla coil, not what we've come to know as a Tesla coil. But that's how you get capacitance. I'm not sure. Yeah, that's how you get capacitance in a coil, and so it is different. It's not the same as having a capacitor on the outside. I don't know. This guy wasn't thinking. He wasn't thinking of Tesla. Well, a lot of people don't like to think of Tesla. They think, well, He's not an authoritative source just because he has patents. Okay, whatever. Funny. If they work. Well, whatever. uh, we don't know that. Oh, okay, right, yeah.